Ah, Sheila. Back from your stroll around the grounds? Yeah, boss. Nothing to report? Everything seemed to be in order? Right, boss. Nothing to report. Sheila, I must let you know something. I've always had a gift for intuition. Something about the way I read people's eyes, or in your case, no eyes at all. It may mean nothing, Sheila, but I feel I should let you know, just in case you've begun thinking about ambition again, about the next big thing. Don't ever forget what you are, Sheila, and exactly what that means. Your place is here, where we can take care of you and shepherd you along to the goal we all share. Anytime you might think about doing something rash, remember, you don't have arms, you don't have legs, and, my dear Sheila, you just don't have the heart. Are we clear? Clear as crystal, boss. Good. Now, if you'll excuse me. You're not a mug, Sheila. You're a dancer.
Commence system shutdown.
Good morning, guys. All right, so hopefully, after the last 2 days, you felt pretty good about the idea of working with these sequences in general, whether they're standard finite or infinite sequences or recursive ones, where we have to sort of use previous terms. So now we're gonna, of course, as usual, complicate things by one more step. So what happens if we don't get the original function? In other words, they just give us a series of terms, and we have to build the function based on that. That's what we mean when we talk about writing the general terms. What is the general means by which we produce a sequence? So these problems you're going to do today, and some of them are going to get a little complicated. Don't worry, on the exam and on the test next week, you're not going to see it in quite as bad a shape, but it's something that you definitely want to practice with a little bit. Basically, the skill here is pattern recognition and understanding how that pattern gets built. So in each one of these, we have two jobs. First one's really easy. Second one has some curveballs in it. We're going to write the general formula. That's here. In other words, a sub n. How do we derive these based on what numbers we choose? And then we're going to write what the eighth term is. So whatever a sub 8 would be. And we can't do this part until we do this part because we don't have our roadmap yet. So let's take a look at these five. Well, we've got 1 over 1, 1 over 2, 1 over 3, 1 over 4, and 1 over 5. And remember, each of these five terms was created by plugging a number, 1, 2, 3, 4, 5, into a formula. So if you look at this one, hopefully the thing that most of you will see right off the bat is, okay, there's going to be a fraction over here. Great. Well, what's going to be on the top of that fraction? Well, what's always on the top of that fraction? Well, just 1. Well, what's going to be on the bottom of that fraction? How do we write it? Well, remember, for every number we pick for n that we put into this formula, this is what we get out. So hopefully you can see, well, if I put in a sub 2, I get 1 over 2. If I put in a sub 3, I get 1 over 3. A sub 4, 1 over 4. A sub 5, 1 over 5. Hopefully then, that will allow you to think about it and go, oh, okay, well, what's on the bottom of the fraction in the denominator is just whatever I put in. Well, what's the easiest way to write that in a general sense? Well, that's 1 over n. Take a second and kind of let that wash over you. Should make sense. Well, that makes the 8th term here pretty easy. Well, okay, if the formula is 1 over n, then 8 is my n. I put it on the denominator, in the denominator of the fraction, and I get 1 over 8. Pretty simple all in all there. And then there was this one. Pattern recognition. And you want to look at each of the patterns, or each of the parts of the pattern, piece by piece. So I'm going to put this here so we can work with it for a little bit. All right, so take a look at these 5. Negative 2 over 1, 4 over 2, negative 8 over 6, 16 over 24, negative 32 over 120. Now, don't look for a magic bullet. What I recommend you do is take it piece by piece. So I want you to look and say, okay, what are the patterns here? What are the patterns with negative and positive signs? What are the patterns in the numerator? And what are the patterns in the denominator? Well, let's start with the negative signs. So hopefully everybody can notice, well, our first term is negative, our second one is positive, our third one is negative, our fourth one is positive, and our fifth one is negative. So we need a means of kind of switching off what that's going to look like. And remember, n is going to be heavily involved in our answer. So if we think, okay, well, negative 1 here, but if I square it here, that'll give me positive 1. To the third power gives me negative 1 again. To the fourth power gives me positive 1. To the fifth power gives me negative 1. So what if I wrote that like that? Hopefully everybody kind of gets the idea of what's going on there. So the first part, and there's going to be 3 total parts to this formula, is the part that deals with our negative sign. That now builds a pattern that works for what we have here. All right, well, let's look at our next part, the next pattern. What's going on in the numerators with the actual constant in the numerator? We've got 2 times 4 times 8 times, 2, then 4, then 8, then 16, then 32. Now, you might think to yourself, okay, well, I'm multiplying it by 2 every time. And you wouldn't necessarily be wrong about that. But remember, we always have to relate it back to n. So what's going on here? Well, this is 2 to the first. This is 2 to the second. This is 2 to the third. This is 2 to the fourth. This is 2 to the fifth. Hey, there's that pattern. We've got the first 5 terms, and we can think about that power as 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. So we could write that like that. Take a second to think about it. Negative 1 raised to the n power times 2 raised to the n power. And before we move on to the denominator, check and make sure that that works. Okay, does that get me the right one here? If I plug in 1, negative 1 to the first power is negative 1, 2 to the first power is 2. That gives me negative 2 on top. Or what about the second term? Negative 1 squared is positive 1. 2 squared is 4, excuse me. So that gives us 4 on top. All right, so the numerator of our fraction seems to be in pretty good shape here. Well, what's the pattern on this next one? And here's where I'm going to tell you, be on the lookout for these factorials, because we talked about it for a reason. Remember, what is a factorial? If I give you a number and I want you to give me its factorial, you're multiplying that number by every number below it. So 4 factorial, for example, is 4 times 3 times 2 times 1. This might not come easily. I just kind of want you to understand and start to recognize it. Like you memorize perfect squares and perfect cubes, this is another thing that you can kind of be on the lookout for. Well, 1, that's just 1 times 1. 2 times 1. 3 times 2 times 1, that's 6. 4 times 3 times 2 times 1. You see how each time we add another term, we're multiplying again by the number that produced that term. 120 is 5 factorial, that's 5 times 4, which is 20, times 3, which is 60, times 2, which is 120, times 1, which is still 120. So the pattern down here is n factorial. I know we went from 0 to 100 real quick, if you'll forgive the ancient reference, but I wanted you to see what a simple one looks like and what a complex one looks like. So I already wrote a sub n down here. We don't need it because we've got our formula here. But we do give ourselves room to now work with the 8th term. All right, so that just means everywhere we see an n, we're going to plug in 8. So negative 1 to the 8th power times 2 to the 8th power over 8 factorial. So if you think about that for a second, it might not come readily to you. This part should be pretty easy. Negative 1 is being raised to an even numbered power here, so we know that's just going to be 1, so we can kind of forget about it. Well, what's 2 to the 8th power? It's okay if you don't know that off the top of your head. That's 256. Well, what's 8 factorial? Well, it is really okay if you don't know that off the top of your head. In fact, I tried to be slick about looking down at it, but I'm going to be much more obvious about it. That is, and you plug that into your calculator, 40,320. And you might think to yourself, there's got to be some ways that we can reduce that. And obviously, you can see they're both even numbers, so you've got a lot of ways to go. Obviously, all these 8s being multiplied, all these even numbers, you know you're going to be able to factor this down. So factoring this down all the way, we would eventually get to 2 over 315. So hopefully you can kind of get a sense of how this works. I'm aware that that one is really tough, okay? When in doubt, go through and multiply everything by the common factor, and if you don't get back to the original fraction, you know you did something wrong. So that said, okay, keep this pretty simple. I mean, it's a pretty easy thing for me to say simple after showing you something like this. I want you to dip your toes in the water with this. Remember, what are the keys overall? Look at the form of the terms. If it's a fraction, then obviously our formula is going to be in fractional form. And then look where 1, 2, 3, 4, 5 is used to produce each of the values. Very simple here. Here, if you know you have more than one thing going on, a change occurring in more than one place. Remember, here we have 3. We have a change with the negative sign, and there's a pattern there. We have a change with the numerator, and there's a pattern there. And we have a change with the denominator, and there's a pattern there. We have to make sure that our formula accounts for each one of those components, which this one does. So again, dip your toes in the water with this. Come see me at live conferences if it doesn't make sense, or contact me directly. Good luck. I hope you have a great day. I will see you tomorrow. Got it. Where'd it go?